All right, hi everyone. Here is a review for exam 2. I have about 5 problems that I'll go through. I've already written them out, but I will go through each one and explain. So here's our first question. You have 3 choices in placing your money in the bank account. Bank A, B, and C. And Bank A is compounded annually, B is compounded quarterly, and C is compounded continuously, and different interest rates. So what we're doing is we're kind of looking for an effective interest rate for that 1 year. So if you remember, if it's compounded annually, well, here's Bank A, that's our nominal, but it's already compounded annually, so that is our interest rate. So we're going to get 6.12% per year. Okay. Bank B pays 6% compounded quarterly. So what we need to do is convert that to an effective annual interest rate using this equation right here. All right, 1 plus r over m raised to the m minus 1, where m is your compounded periods. There's 4 quarters in 1 year. And when we plug this in, we get an interest of 6.136%, which is higher. Okay. And then Bank C is compounded continuously, and the nominal is 5.9% continuous. So we got to use the equation here for continuous equations, where K is the number of payment periods per year, and we're only, say we're going to just deposit one time in the year. Well, K would be 1. So then therefore this interest rate would be per year. Okay, so we had a continuous of 6.078%. All right, so anytime you do continuous, whatever number you have underneath here, if it's 4, then it would be per quarter. But here it's 1, so it's 1 per year. Okay, so we would go with Bank B. Okay, so let's move on. Question 2. What is the future worth of a series of equal end of month payments of $1,500 if the series extends over a period of 8 years at 9% interest compounded at these given values? All right, so we know that A is $1,500 per month. And what we're going to do is we're going to use N. It's going to be 96 months. So for every one of these, A, B, and C, we need to find the interest rate per month. So we got to convert from quarterly to month, monthly to month, which we already have, continuous to a monthly. So we're going to use basically 96 months because we're doing months, and this is our equation right here. F equals A, F over A, I, N, where basically N is 96 and A is 1,500. We just need to find the A per month for each condition. So let's go to, let's do monthly first because that one's easier, so part B. Because the deposits, payments are per month and our interest is per month, then we can just use I equals R over M because they're both the same. And again, if you're stuck, I gave you that little sheet, a little chart where it says, for annual payments, are they the same? Yes, use this equation for the interest rate. So we find that it's 0.0075 per month. Okay, so we converted the compounded quarterly to month. Compounded monthly to per month. And then we plug that equation into the F equation and we get 209,784. Okay. Now let's jump to continuous. Well, we know we have to use this equation right here for continuous, but the K now determines what we need to what is it per month, per year, per quarter, whatever. Well, we know there's 12 months, all right, and we're paying that. We're doing payments every 12 months, so K is 12. We get our interest rate to be slightly higher than the previous one in part B. We plug that in, and why don't I write per month here? Okay, and we get 210,097. Okay, so in continuous, you just got to figure out what your K value is, and that determines if it's per month or per year. So now we've converted B and C, basically, which said compounded monthly to per month, compounded continuously to per month. Now we need to do compounded quarterly to per month. And because the number of payments in Part A is less frequent than the number of interest, okay, we need to use this equation here. And again, that's following your chart. And some things you need to remember. M is C times K, and that M is the compounding periods per year, so that's 4. That goes down here. K is the number of payment periods per year, which we already talked about, which was 12. And then in order to get C, we can actually take M and divide by K, or it's the number of interest periods per payment period, which is 1/3. So we plug that back into the equation, our values, and we get an interest rate per month. So we now converted compounding quarterly to per month. Plug that back in and we get 209,170. Okay, so technically the continuous one I would want, as it gives you more money in the end. Okay, so let's move on to question 3. A married couple is trying to finance their 3-year-old son's college education. Money can be deposited at 6% compounded quarterly. What end of quarter deposit must be made from the son's 3rd birthday to its 18th birthday to provide $60,000 on each birthday from the 18th to the 21st? All right, so a few things. They're basically going to deposit from his 3rd birthday, okay, the first 3 months after his 3rd birthday, quarterly deposits. And the interest is compounded quarterly. Okay, so that's important to know that they're both the same. Then on his 18th birthday, okay, the same day there's the last deposit, they want to take out $60,000 when he's 18, and then when he's 19, 20, and 21. So here, if you notice, each one of these blue is a year, but there's basically 4 quarters in a year. Okay, so this is basically from 0 to 4 I did, and then I said, okay, I can do all that to 18. Okay, so what I did is, I'm assuming his birthday is the 3 months exactly after his 3rd birthday, so we're going to start depositing. So these purple ones are all A values, all the way to his 18th. And then we're going to take out exactly on his 18th birthday, $60,000. And then the year later, another 60, and another 60, and another 60. Okay, so we need to figure out what these A values are. So this is the approach I took. Basically, what I'm going to do is, if we look down here, we know we're still assuming the interest is 6% compounded quarterly, and we know how many years, so we can figure out how much money is actually right here on his 18th birthday to distribute this $60,000. And we're going to assume that's a present value. All right. So again, we're converting these 60,000s back to year 18, and we now know a present value here, which is technically the future value for this cash flow. And if we know the future value here, we can then backtrack and figure out what the annual value is. So I took it going the other way. So if we need to know A, we want to find A, we need to know the future value. Okay, and then here's the ratio, A over F, comma I, comma N. So the question is, what is F, I, and N for the first cash flow? Well, F is basically your p-value based on 18 to 21. Okay, so we'll find that in a second. Your interest rate, because they're both being deposited and the interest is both compounding, we can divide by 4, and we get 1.5% per quarter. So the interest or the deposits are going to get that. How many quarters are we doing? Well, there's 15 years from his 18th to 3rd birthday, and there's 4 quarters in a year, so there's 60 quarters. Okay, so now we kind of have I and N. We still need to find F, which is really P. So what we need to do is we need to figure out, if I go back up here, the present value right here on this line. So we need to convert these 3 values, which are annuals, back to this and add this 60,000. Okay, so here's on the 18th, the 60, and then we're converting these annual payments back 3 years. Okay, so A2 is 60,000, and we're bringing those annual payments back to 3 years. Okay, so N is year 3. I we need to find, and we know this. I is just because we know that it's 6% compounded quarterly. We can find an effective interest rate, which is per year. So I can put that in here. This is per year because we're using years here and up here. Sorry, we're using years. Watch my cursor here. We need that to be per year, which we can find an effective interest rate per year. All right. So M is 4, which is the number of compounding periods per year. And we find that the interest per year is 0.06136. So we can plug that back into our equation here to find the present value. We found it to be $219,900. So this is the amount that we need at the end of his 18th birthday to take out 60 for the next, basically, this counting this year plus 3 more. And we know that as the future value from the cash flow for his deposits between his 3rd and 18th birthday. And we now can go back to use this equation where A equals F, A over F, I, N. We know that F is equal to P. This is, again, back to the deposits. So the interest rate is 1.5%, and we're doing it for 60, 60 quarters, right? Yeah, just want to make sure. So then we end up getting basically 2,286. So we need to put that in every quarter until his 18th birthday in order to get $60,000 out for like basically on his 18th plus his next 3 years. All right. So let's move on to this one. Very kind of similar. What is the amount of quarterly deposits, so these lines here, such that you'll be able to withdraw the amount shown in the cash flow diagram, all right, if the interest rate is 8% compounded quarterly? So all they're saying is this top is a different cash flow than the bottom. 2 separate cash flows. And basically we're trying to figure out when they match. So what we need to do is we need to move the top and the bottom all the way to this future value here at year 8. So the future value of the black lines is F1, and the future value of these blue ones is F2. All right, so we end up having P1, which is 1,500, then F over P, comma I, comma N, plus 2,500. Okay, so we're converting this 1,500 up 4 years. So it goes 1, 2, 3, 4. And then we're at year 8, so that's why we add 2,500. And the interest is per quarter. That's what we need to find. So it's our nominal over our M, which is 4. So we get 2%. And that's 2% everywhere because it's the same. So that covers F1. And then F2, this first part is A, which is this what we're looking for. F over A, comma I, comma N. I is 2%. N is 8. Okay, but if you remember, typically we don't have this value at 0 when we're trying to find A's. Okay, so we need this is basically some sort of present value that we're converting to a future value. Okay, so this first term just corresponds to 1, 2, 3, 4, 5, 6, 7, 8. But this right-hand term right here corresponds to this value at year 0. And we need to convert that to a future value, okay, 8 quarters ahead. Okay, but the P1 is really A. So we have 2 terms here, 2 terms here. We can then figure what these ratios are and solve for our A, which is 422.74 roughly. Okay, so again, convert 1,500 up, which is here. Add the 2,500, which is here, because we're at year 8, because we're looking for the future value. Here, this part right here I'm circling corresponds to 1 through 8 for A, but then we need to get this last value at year 0 because typically we don't do that when we have A values. So we got to move that value up 8 quarters. Okay, because it's 1, 2, 3, 4, 5, 6, 7, 8. Alrighty. Okay, the last question. All right, so basically, a person has $4,000 in a savings account at the beginning of the calendar year. The bank pays 6% per year compounded quarterly. Okay, and this table shows the transactions occurred during the calendar year. All right, so we have effective dates here. Okay, and then we have deposits and withdrawals. And basically what we're doing is deposits are made at the end of the interest period. Okay, so the end of the interest period, okay, could be, basically would be a March, the end of March, the end of June, the end of September, and end of December, okay, right at the end. Okay, so there's no interest being incurred on them. The withdrawals were made at the beginning of the interest period, okay? So those would be like the next month, so April 1st, just before we started getting any interest. Okay, so there's a time between where, like, pretend it's the end of the day of the bank, and we deposit money, and then the next day, opening rate up, we take out money. Okay, so that's how we're going to look at these. And what we're trying to figure out, the future value at the end of the year. All right, so basically what you need to do is you need to find the deposits, subtract the withdrawals for every quarter. So here we have 4,000, but then we subtract 175, okay, because the withdrawal, we're assuming it's made at, what was the withdrawals? At the beginning of the interest period, okay, at the very beginning, just before we start getting interest. So we subtract those two, and then we convert that value to a future value in basically 4 quarters. Okay, so after June 1st, what do we have? That's that money, and we convert that. Then the second quarter, or the quarter we need to convert, we need to find values and convert it 3 quarters to find the future value, is basically you have April, May, June. Okay, so after April 1st, as soon as the bank opens, we basically take the money out, but then we start getting interest. All right, how much money do we have? Well, we take this 1,200, all right, okay, which is in the March, and then we need to subtract the 1,800. Now the 1,800 is, we got to look at the April 1st dates. You see these underlined purples? And we have to add all those. Okay, because April 1st, we're assuming it's at the very beginning of April 1st. As soon as the bank opens, we withdraw that money. Okay, and then they start getting interest. So you have to subtract their withdrawals. Then we convert that to a future value for 3 quarters. Then the next quarter, we have 180. Okay, which is, we're in what month now? Basically, you're saying after July 1st, what do we have? Okay. So we take 180, which is 65 plus 115, because we're in June. Okay. So 180, 65 plus 115, and then we got to subtract 800. All right, which is coming from July 1st. Okay, then we convert that 2 quarters. All right, then we need we have a couple more quarters. All right, we have 1,600, which is September 30th. Okay, so we're in this quarter. And then we need to subtract, basically, after October 1st, we have actually 1 and 2. So 350 plus 750, which is 1,100. Okay, and then we need to convert that to a future value in 1 quarter. And then the last thing is, the last quarter, we actually deposit 2,300, so we add the 2,300. All right, so basically what you're looking at is some kind of cash flow where 3825 is this number. Okay, 600 is that number. Okay, and don't worry about the negative. I'm just kind of showing you, like, okay, there's actually negative 600 here, right? And then you have 620. This would be a negative 620. Here you would have 500, and then finally 2,300. So basically, actually I can fix those. So the withdrawals are more. So why don't I just move those then? Is the 500 negative? No, just those two. So going up 600 and then 620 and then 500 and then there. So basically when the down arrows meaning you're depositing and actually you're actually taking more money out with the black ones, okay? And then you're trying to basically figure out what the future value is here. Okay, so don't get too lost in this. I'm just showing you what they're trying to do is every quarter they figure out what their deposits and withdrawals are, and then they find a future value based on those. All right. So you've done it's very similar to what you've done in the past. You're just now looking at it in terms of a deposits and withdrawals kind of concept. Okay. And again, they're just looking at, okay, let's do the first one here. They have 4,000 at the beginning of the year. Okay, but January 1st comes, the bank just opens, we withdraw that. And really you have 3,825 that you're converting to a future value. All right. And then the quarter, basically, you have January, February, March. Okay, that's where the 1,200 comes in, the deposits, and then you subtract your withdrawals for kind of that month. So, and I didn't write this, but you end up getting with all this F equals 5,601. So. All right. I just wanted to do this to hopefully help you with any issues or help you with the test questions. And if you have questions, please feel free to email me. All right. Thank you.